We've got 4 squared plus 3 squared equals x squared. Well, we can simplify the number portions. What's 4 squared, Marcos? Nope. 16, okay? The square root of 4 is 2. 4 squared is 16. And 3 squared, Samantha?
9.
Good. So this is 16 plus 9 equals x squared. 16 plus 9 is what, Nico?
25.
25. And what squared gives us 25?
5.
X equals 5. Okay? You can also think about it as taking the square root of both sides. This square root and the squared will cancel. And you'll end up getting the square root of 25, which is just 5. Now, sometimes in algebra, you will have seen whenever you take the square root, you should put a plus or minus in front of the square root, okay? We're only dealing with positives because we're talking about the sides of a triangle. The side of a triangle cannot be a negative value, so we're just going to leave it like this, okay? That's the reason that we're not adding the plus or minus. Okay, number 3, I'll do this one in blue. When we square a fraction, all you do is you square both the numerator and the denominator. So in number 3, this becomes 5 squared over 2 squared minus x squared equals 1 squared over 3 squared, okay? Now, this one gets a little messy, okay? But keep in mind, in this chapter, you guys are going to have a calculator, okay? So all these messy situations, you're going to have a calculator to help you out, to simplify any fractions, do all that stuff. Okay, so 5 squared. Alexandra. We're looking at that numerator. Remember, 5 squared is just 5 times 5, which is 25. And then over 2 squared, Samantha? 4. David, what is 1 squared?
1.
And 3 squared?
9.
9. So we have 1 over 9 on the other side. Now, we're solving for x. So, Noah, what do we need to do in order to solve for x? Any ideas? Okay, I'll help him out.
I'm not really sure either, but I think we should do the square root thing.
Okay, eventually we're going to do the square root. But we need to move everything over. What's there on the left side that we need to get rid of?
25 over 4.
Good, so let's subtract 25 over 4 to both sides. So we've got negative x squared equals 1 over 9 minus 25 over 4.
Would we have to make a common denominator?
Very good. We have to make a common denominator, okay? So in order to make a common denominator, you're just going to multiply each of them by the denominator of the other one. So for example, 1 over 9, you're going to multiply by 4 over 4. 25 over 4, you're going to multiply by 9 over 9, okay? And watch what happens. We're going to get negative x squared equals 4 times 1 is 4. 4 times 9 is 36. Minus 25 times 9 is 225. I did this earlier. That's the only reason I know this, okay? And then 4 times 9 is 36. Remember, you are going to have a calculator to calculate all of this.
Wait, how did you get 4 over 36?
So I did 4 times 1 and then 4 times 9.
Where did you get 4 over 4?
Okay, so the reason I'm multiplying by 4 over 4 is I want to multiply by the denominator of the other one.
Okay.
And I want to multiply by the denominator of this one to the other one. Do you see how I multiply by 9 over 9 and 4 over 4?
Okay.
That way I get the same denominator for both. Do you see how now I have 36 for both of them?
Yeah.
Okay. Now I can just subtract. What is 4 minus 225? Yep, negative 221 over 36. Now, we can divide by -1, multiply by -1. Just get rid of those negatives. So it's x squared equals 221 over 36. And then you take the square root, so you're going to get x. Oops. Sorry. X. Where is my pen? X equals the square root of 221 over 36. And all you do is you plug that into your calculator. You take 221 divided by 36. You should get like 6.138. And then you take the square root of that and you get 2.48. Okay, I know some of you guys are confused. The more we deal with these square roots and these squares, the more it'll come back to you, all this old algebra that we're dealing with. Okay, last one, number 5, okay? Some things that you guys need to know about number 5. Whenever you have a square root and you're squaring it, they cancel, okay? So that square root and that squared will cancel. You're just gonna be left with 5 plus x squared equals 12 squared. Now, 12 squared, we're just going to write as what? What's 12 squared? Who's good with their exponents? Samantha? 144. Very good. How do we solve for x? Well, we need to get rid of that 5. How are we going to do that? David? Thank you, David. So we've got x squared equals 139. What do we do next? Good. We take the square root of both sides. These are going to cancel with the x. We're going to get x equals the square root of 139, which is 11.79. Remember, you will have a calculator on the test.
Can we round these?
Yeah, I would like you to round it to the nearest hundredth. So that it's currently rounded. Like, the actual answer is like 11.789826. So you just round it to 11.789. Okay, I know some of you guys probably have questions on this warm-up. Don't worry, I just wanted you guys to see.
Please pardon the interruption. Boys tennis may be excused at this time. Boys tennis may be excused at this time. Thank you.
Just wanted you guys to see some of the algebra that goes into these types of problems, okay? All right. Let's get started with our lesson. Is that enough?
Yes, thank you. That's good. Can you scroll up to the first?
Okay. Chapter 9, Section 1, the Pythagorean Theorem, okay? And yes, it sounds way fancier than it actually is, okay? Theorem 9.1. This is our first theorem. It involves the Pythagorean Theorem. In a right triangle, you need to underline, highlight, do something to exaggerate the fact that it says in a right triangle. The Pythagorean theorem does not apply to any other triangle other than a right triangle. The square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So in this case, we've got a squared plus b squared, which are both of the legs, and that is equal to c squared. Okay, make sure you label that A and B are your legs and C is your hypotenuse. What kind of triangle does it have to be in order to apply the Pythagorean theorem? A right triangle, okay? That is the most important part of this entire theorem, okay? It must be a right triangle in order to apply the Pythagorean theorem. All right, nothing to be done on these slides. These are just some examples of common triples, okay? So these are where the Pythagorean theorem would work perfectly, okay? The largest number is going to be your C. So 5, 10, 13, 17, and 25 will always be your C. The other two will be your A and B, okay? It doesn't matter which one you make A, doesn't matter which one you make B, but that's how these are going to work. Okay. In our first example, we want to find the values of x and y for each of these triangles, okay? For A, how do we know we can apply the Pythagorean theorem? Samantha? It's a right triangle. We know it's a right triangle by this bad boy right here in the bottom left corner of the triangle, okay? Tells us that there's 190-degree angle, therefore it's a right triangle. What I need you guys to do is label each of the sides. This 5 will make our A. You could have made it your B, it doesn't matter. This 10 will make our B. And this Y is going to be our C. And we just write the formula down. In order to apply the Pythagorean theorem, it's A squared plus B squared equals C squared. So 5 squared, because 5 was A, plus 10 squared equals Y squared. Nico, 5 squared.
Okay, 25.
Nico, do you really think I don't know that you're not taking notes?
I'm writing it down.
No, you're not. Don't lie to me. Show me.
I haven't done this page because I just wait till it's over.
Ten squared, Samantha. 100. So this is 125 equals Y squared. What do we do? Noah.
Next we need to do the square root.
Take the square root of both sides. And we get Y equals the square root of 125. I don't know off the top of my head because it's a decimal. But we plug it into our calculator. We get 11.18.
How do you square root it on the calculator?
So you just plug in the number and there should be like a radical sign. Do you see that radical sign?
No, it's not showing.
Let me see.
So after like clicking,
Hold on.
oh wait,
Yeah, you gotta turn it sideways.
it's not showing.
Turn off your look.
It is off. Wait, you might be doing it. Oh, okay. Like that?
Yep.
Okay, yeah. Thank you.
Okay. Second example, example B. Are we gonna apply the Pythagorean theorem?
Yeah.
How do we know?
Do the right triangle.
It's a right triangle, okay? So let's go ahead and make each of these a letter. This one's a little bit tougher, okay? 5 is gonna be what? A. It could have been B. Either way, it's gotta be a leg though. Why is it a leg?
Because it's one of the sides of the right triangle.
Very good. It's one of the sides that includes the right angle, okay? And what about Y minus 1? What's that gonna be?
B.
B. And Y? C.
I think you're asking like why.
Oh. Okay. And now we've got a squared plus b squared equals c squared. A is 5. Let's square it.
25.
Yep. So this is 25. Plus b, which is y minus 1. We're also going to square that. Equals c, which is y squared. So 5 squared is 25. If we take y minus 1 and we square it, that is the same as y minus 1 times y minus 1. So what we're going to do is we're going to write this as y minus 1 times y minus 1 equals y squared. Now, what's going to happen next is something called the FOIL method, okay? Now, FOIL was something that you guys should have learned in algebra. I'll write it over here, F-O-I-L, and draw an arrow to where I'm applying it. If this does not make sense to you, you need to go back and review the FOIL method, okay? This is something very important that we will be using in this lesson, okay? What the FOIL method says is it stands for F. F stands for first. So the first from this parentheses gets multiplied by the first from this parentheses. The O stands for outer. So both of the outer terms get multiplied by each other. I stands for inside. So both the inside terms, the -1 and the y. And L stands for last. The last term in this parentheses and the last term in this parentheses. That's called the FOIL method. If you don't know about the FOIL method, you can always look it up, okay? This is old algebra. Okay, so we've got 25 plus the y times y is going to give us y squared. The y times -1 will give us minus y. The -1 times y will give us minus y. And the -1 times -1 will give us plus 1. Now, if you are completely lost at this point, do not freak out. We will do more problems like this. Samantha, what's up?
For the minus y, since there's 2, can you square it?
We're going to combine them, yes, because they're like terms. But we're not going to square it. We're just going to write minus 2y, okay? Okay, so then this is equal to y squared. Now look what happens. If you ever get a question like this, okay, and it's kind of complicated, right? Something's going to make it very easy. If we were to combine like terms, let's simplify this left side. Those two minus y's will combine to give us minus 2y. So we've got 25 plus y squared minus 2y plus 1 equals y squared.
Don't you combine like terms 2 with the 1 and then it becomes 26?
Good. We can combine like terms with the 1, and this will be 26 plus y squared minus 2y equals y squared. There's one other set of terms that we can combine. Does anyone see it? Y squared and y squared. So let's go ahead and move the one on the left over to the right. We're going to subtract y squared, subtract y squared. This will give us 26 minus 2y, because these cancel, equals, what's y squared minus y squared? 0. Now we're just going to add 2y to both sides. We've got 26 equals 2y. How do we solve for y? Just divide by 2. 13 equals y. So guys, these ones kind of can be a little fun, okay? Once you plug in your A and your B, it's a lot of algebra, and then it should simplify to something pretty nice, okay? If it's not super nice, you maybe are doing it wrong, because I'm not that mean. I won't give you anything like that crazy, okay? I'm a little mean, but I'm not that mean, okay? So 13 equals y is the final answer. We solved for y. Questions on this one? Okay. One more involving this Pythagorean theorem with these types of examples. Okay, C. All we need to know is we need to figure out x. Let's make x A, B, or C. What's it going to be? A. What's 3 going to be? And what's 3 root 2 going to be? C. So all we do is plug these into our formula. We've got a squared plus b squared equals c squared. A is now x squared plus b is now 3 squared equals, and then c is now 3, the square root of 2 squared. Okay, so now let's simplify the number portions. X squared is going to stay the same, plus what's 3 squared? 9 equals, now this squared, how is this term 3 root 2 different than y minus 1 squared? What's the difference there? Think about how we're going to treat 3 times the square root of 2 and y minus 1.
Isn't the square root and the square canceled out?
Yes, but how is that, like, if we were to look at y minus 1 versus 3 root 2, what's the big difference here? Do you guys see it? It's the number of terms. Yep, Megan is absolutely right. These two are being multiplied. These two are being subtracted or added, okay? When they're being multiplied, look what happens. All you do is you distribute the squared. So this is going to be 3 squared and the square root of 2 squared. And just like, who said it? Was it Juliana?
Yeah.
The square root and the squareds cancel. Very good. So we've got x squared plus 9, plus 9 equals 3 squared, which is 9, times 2. This is x squared plus 9 equals, 9 times 2 is just 18. We subtract 9 from both sides. We get x squared equals 9. We don't even need a calculator for this one. What is x going to be? 3. Find the length of a diagonal of a rectangle with length 8 and width 4. Really easy question. Here's a rectangle. Its width is 4. Its length is 8. Here's a diagonal. Question. If we know that the angles of a rectangle are 90 degrees, do you guys see anything special about the diagonal? Samantha?
Oh wait, aren't they both equal?
Ah, yes. What else? Do you guys notice a certain shape now?
Triangle.
What kind of triangle?
Right triangle.
A right triangle, okay? I noticed a right triangle, okay? I'll highlight it so you guys can all see it. Here's our diagonal. Here's our hypotenuse. Here's one leg. Here's our other leg. Do you guys see that? So it wants us to find the length of the diagonal. What's 4? A, B, or C?
A.
It could be A, it could be B. 8, if 4 is A, 8 is going to be B. And then our hypotenuse will be C, or the length of the diagonal. So all we're going to do is plug that into our formula. A squared plus B squared equals C squared. A is 4, so 4 squared plus B, which is 8 squared, equals C squared. Noah, what's 4 squared? Kale, what's 8 squared? And this equals C squared. 16 plus 64 is 80, equals C squared. Samantha, how do I find C?
Divide by C. Oh no, square root.
Take the square root of both sides. This is going to cancel with this, and we're going to get C equals the square root of 80, which is, let's see. Someone confirm that you got 8.94.
Yeah.
You got that, Samantha? Okay. Can I get a Zoomer to confirm that?
Yeah, I got that.
Thank you, Juliana. Okay. Any questions on example 2? Okay. Was there a question? No? Okay. Example 3. The diagonals of a rhombus have lengths 16 and 30. Find the perimeter of the rhombus. So, I don't know if you guys remember what a rhombus looks like, but a rhombus was a parallelogram where each of the sides is the same length. So this is not drawn to scale, but each of the sides is the same length. Now, a rhombus is cool because its diagonals do what? Does anyone remember? They bisect each other. So this side is equal to this side, and this side is equal to this side. What else do they do? Come on, who's been paying attention the last few months? They do intersect, but there's something special about their intersection. There you go. Very good. It's perpendicular. So all of these are right angles, okay? Does anyone see right triangles?
Yeah.
Yeah, we see them, right? How many are there?
4.
There's 4 of them. Very good. There's a right triangle here at each of those triangles, okay? But we're only going to use one. Now, it told us that the length of its diagonals are 16 and 30. So, without me giving it away, does anyone think that they know the length of this side and the length of this side of our right triangle? If our diagonals are 16 and 30, close. So let's say we knew that this whole length from here to here is 30, and this whole length from here to here is 16. Any ideas on what those two legs of our right triangle are going to be? Say it again, Alicia. Very good. How'd you get that? Very good. Since the diagonals bisect each other, we just take the length of the diagonal and we divide it by 2. So we've got 15 for one side and we've got 8 for the other. All we need to find is our hypotenuse. So let's go ahead and make 8 what? A or B? Or C? David, what's 8 going to be? It could be A, it could be B, okay? Let's make it A, let's make 15B, and now we just solve for C. So we've got 8 squared plus 15 squared equals C squared. 8 squared is 64 plus 15 squared. I'm going to use my calculator, which is 225, equals C squared. These two added together is going to give us 289 equals C squared. The square root of both. These cancel, and we get C equals the square root of 289, which is 17. So we found out that this is 17. How would we find the perimeter of the rhombus? How would we find the perimeter of the rhombus?
Since all the sides are the same on a base 17, you should multiply by 4.
Very good, Juliana. Since all the sides are the same for a rhombus, each of these is 17. So we just take 17 and we multiply it by 4. 17 times 4 is going to give us 8 to 68. So perimeter. $68. Very good. Okay, in example 4, the reason I saved this one for last is because there's like something a little bit special about it.
It's bisecting.
It is bisecting, but we got to figure out why it's bisecting. Guys, if you were to look at the entire pink triangle, right? The whole pink triangle, and describe it to me. It's a special type of triangle. How would you describe it? There's a special word for these types of triangles. Look at the pink triangle as a whole, not as two separate triangles. It is acute. Good. Let's think a little bit more about like the lengths of the sides.
Isosceles?
Ah, very good, Karen. It is isosceles. Why is it isosceles?
Two sides are bigger than one.
What do we need for it to be isosceles, guys?
Two of the sides to be congruent.
Good. And one side is x and the other side is x, right? So that means that these two angles are the same. We know that these two are 90 degrees, right? And we know that these two angles must be the same as well. So these two triangles split by this line down the middle are going to be exactly the same. So if this whole side length is 6, what's going to be the length of each of these legs?
12.
Nope. If that whole side length is 6, what's going to be the length of each of those legs?
3.
3 and 3. Okay? It's that 6 divided into 2 parts. Okay? So now we've got 2 right triangles. So let's solve for x. What's my A going to be?
3.
Good. What's my B going to be?
3.
Nope. The 6. And my x is going to be C. You could have used either right triangle, okay? You could have used this one or the one on the right side. Do you guys see that?
Why is C not the 6 though? Because 6 is the biggest number in the triangle.
Because we don't, well, x is going to be bigger. But check this out, Teresa. You see this right angle mark?
Yeah.
Remember, your legs form the right angle. So your hypotenuse has to lie opposite that angle, which is the C. Do you see that?
Yeah.
Okay, so we've got A equals 3, B equals 6. So let's just write A squared plus B squared equals C squared. A is 3 squared. Add that with B, which is 6 squared. And we're going to get X squared. 3 squared is 9. 6 squared is 36. 9 plus 36 is going to give us 45. And in order to solve for x, we're just going to take the square root of both sides. And we'll get that x equals the square root of 45, which is approximately 6.71, I believe. Let me double check that. 45 square root. Yeah, 6.71. Triangle. What this theorem is saying is that the Pythagorean theorem works in reverse. If you have 3 sides of a triangle and the longest one squared is equal to the other 2 sides squared and added together, then we know that triangle must be a right triangle. One of the angles must be 90 degrees, okay? It's just the Pythagorean theorem, which we already learned, in reverse. Theorem is theorem 9.3. It says that the Pythagorean inequalities theorem. If the square of the longest side of a triangle is less than the sum of the squares of the other 2 sides, then the triangle is an acute triangle. If c squared is less than a squared plus b squared, then the triangle is acute. C squared bigger than a squared plus b squared, then the triangle is obtuse. We've got those 3 scenarios, okay? This is theorem 9.4. We've got some examples. So the sides of a triangle, what's up? Okay, the sides of a triangle have the lengths given. If the triangle is acute, is the triangle acute, right, or obtuse, okay? So when we're given these types of problems, the first thing I want you to do is label an A, a B, and a C. Your C is always going to be your largest side. So for example, in A, we've got 20, 21, and 29. What's our C going to be?
29.
29, very good. And your A and B are interchangeable. It doesn't matter which one you make which. I'm just going to put A as 20 and B as 21, okay? So what we do for A is we take A squared plus B squared, and we're going to compare that to C squared, okay? Now, we don't know if it's going to be bigger than, if it's going to be less than, or what's going to happen in the middle. So we're going to leave this blank for now in the middle, okay? Then we're going to compare them at the end. So A squared is going to be 20 squared plus B squared, which is 21 squared. And then C squared is just 29 squared. Now, remember, in this chapter, you will have a calculator, so I'm going to take mine out, which, if I could find it, oh, it's right here. It's going to be 20 squared, which is 400 plus 21 squared, which is 441. So this is 841. And 29 squared is 841. Are they equal, bigger, or less than?
Equal.
Equal. So what kind of triangle do we have for A? It's a right triangle. Very good. Okay? So A gives us a right triangle with the sides 20, 21, and 29. Okay, let's take a look at B. So in B, we've got 20, 21, and 30. What's my C going to be? 30. And A and B, it doesn't matter which one you make which. A will make 20, B will make 21. So we're going to compare A squared plus B squared and compare that to C squared. So A squared will be 20 squared plus 21 squared, and C squared is going to be 30 squared. Now, we already did 20 and 21. We got 841. Now, 30 squared is going to be like 900. Which one's bigger, 841 or 900? 900. So, if your C squared is bigger, do we have a right triangle, acute, or obtuse? Obtuse, okay? So this is an obtuse triangle. Which makes sense, because if you had a right triangle with the side, your hypotenuse as 29, if you extended that hypotenuse to 30, you would no longer have a right triangle. You would make that angle, that 90-degree angle, obtuse, okay? Because you're just increasing that last side. All right, let's check out C. For C, we've got 5, 6, and 8. Which one's C?
8.
Which one's A?
5.
And B? 6. Okay, if you made 6A and 5B, that would be fine as well. Excuse me. Okay, so C, we're just going to compare them. So we're going to do A squared plus B squared and compare that to C squared. A squared is 5 squared plus B squared is going to be 6 squared. And C squared is 8 squared. 5 squared is 25. We add that with 36. And 8 squared is 64. 25 plus 36 gives us, I believe, 61. Which is less than 64. When your C squared is bigger, obtuse. We starting to get the hang of this? Okay. Now, when it involves the radicals, okay, it's easier than it seems, okay? So in D, when we're looking at to find the largest side, okay, and we have something with a radical and something without a radical, what I want you guys to do is put everything under the radical, okay? So 4 and 8, we know that 8 is bigger, so we're not even going to compare 4. 4 is out of the question. 4 is either going to be A or B, so let's just put A next to 4, because that has to be the smallest side. But 4 times the square root of 3, we have to compare that with 8. Now, some people already know it. They're like, well, the square root of 3 is less than the square root of 4, and 4 times 2 is 8. But if you don't see that initially, do it this way. Put everything under the radical. So 4 root 3 is going to be the same as the square root of what times the square root of 3? What is 4 written as the square root of something? What's that?
1.
No. If we were to take 4 and write it as a square root of something, what would it be? What's 4 squared? 16. So let's put 16 under the radical. Do you guys agree that the square root of 16 is the same as 4? Right? All we do now is we take that 16 and we multiply it by 3. So we're going to get the square root of 48. Okay, now we're going to do the same thing with the 8. We're going to take 8 and we're going to make it into a square root. 8 is the same as the square root of what? Nope.
64.
64. Okay? Which one's bigger, the square root of 64 or the square root of 48? Square root of 64 is bigger. So 8 has to be our C. And 4 root 3 is going to be our B. Okay? This is all letter D, by the way. Okay, so we've established what's A, what's B, and what's C. Now all we do is compare them. So we're going to take A squared plus B squared and compare it to C squared. A is 4 squared plus B, which is 4 root 3 squared, and we compare that with C squared, which is 8 squared. 4 squared is 16 plus the squared gets distributed. So this is 4 squared times 3. And this is just 64 over here. So this is 16 plus 16 times 3 compared to 64. This is 16 plus 48 compared to 64. And this is 64 in comparison with 64. These are equal. So what kind of triangle do we have?
Right?
It's a right triangle. Very good. So this is a right triangle. Okay, last example. E. So for E, guys, we have the sides 1, 3, and the square root of 10. What's the smallest side, obviously? 1. So that, we'll just put an A next to that one. That one will be our A. Now, there's no way to compare 3 and the square root of 10 unless you knew what the square root of 10 was, which most people don't, okay? So just take that 3 and convert it into a square root. So 3 is the same as the square root of what? What's 3 squared? 9. So 3 is the same as the square root of 9. Which one's bigger, square root of 9 or square root of 10? Square root of 10, okay? So square root of 10 has to be our C. That's the biggest side, okay? And so our B must be the 3. Do you guys follow me? Okay. So now in E, all we're going to do is take our A squared plus our B squared and compare it with our C squared. Our A is 1 squared, our B is 3 squared, and our C is the square root of 10 squared. 1 squared is 1 plus 3 daisies. 9. And the square root of 10 squared is what? Nope.
100?
Nope. What happens when you square the square root? They cancel. So it's just 10. What's the comparison with 10 and 10? They're equal. When A squared plus B squared equals C squared, what kind of triangle do we have?
Right.
It's a right triangle. Now I need us to go all the way back to example 4. which is 9. Oops.